For decades, the Big Bang has been seen as the universe's first cry of birth. But what if it was only the final echo of a colossal collapse, whispered through time? What if the night sky is not opening above us, but gently enclosing us, like the ancient heart of a black hole? Leave your thoughts in the comments, because the next question pulls us even deeper. What if the Big Bang wasn't the beginning? What if the Big Bang was not a birth at all, but the bruise left behind after something unimaginably heavy fell inward? For many generations, we were taught a clean story, a bright beginning, a single moment when everything burst into being and the universe took its first breath. It is a comforting picture because it places a candle at the start of the corridor and tells us that history has a doorway. But sometimes the cosmos does not offer doorways, only thresholds. And sometimes the most frightening possibility is also the most strangely beautiful. What if our universe was not born in an open field of nothingness, but formed inside a boundary we cannot cross and cannot even properly imagine? What if the night sky above your roof is not an endless dome of freedom, but the inner curve of a vast gravitational embrace? A black hole so enormous that it contains our galaxies the way an ocean contains a drifting lantern. When I first encountered this idea, it felt less like a claim and more like a mirror held up to our ignorance. It asked me to notice how many of our strongest statements are really habits dressed as certainty. The phrase, "the beginning of the universe," sounds like a final answer. Yet even the best cosmology admits it is a model stitched from light that has traveled for billions of years and arrives already tired. We interpret that light like archaeologists reading smoke stains on an ancient ceiling and trying to reconstruct the entire fire. A black hole universe hypothesis does not have to be true to be useful, because it forces us to examine what we think we know about edges and origins. A black hole is often described as a devourer, a cosmic mouth that never closes. Yet in physics, it is also a boundary condition, a place where the rules of ordinary intuition lose their authority. The event horizon is not a wall made of stone or metal. It is a line drawn by gravity itself. Cross it, and the universe changes the meaning of escape. Outside the horizon, you can always imagine turning around, even if you do not have the fuel. Inside the horizon, the concept of turning around becomes like trying to swim upstream through time. It is not simply difficult. It is not allowed by the geometry. That alone should make us pause, because our observable universe also has a horizon of sorts, a limit beyond which light has not had enough time to reach us since the earliest moments we can describe. And the mind cannot help wondering if horizons rhyme with horizons for a reason. Stephen Hawking once offered a line that I keep returning to, not as proof, but as atmosphere. Black holes are not as black as they are painted. That sentence carries an entire revolution in quiet form, because it suggests that even the darkest objects are not purely endings. They leak complexity. They demand accounting. They refuse to be simple metaphors of death. And if black holes can radiate and change, if they can possess temperature and entropy and a kind of bookkeeping of information, then they begin to look less like tombs and more like engines of transformation. To picture the idea more clearly, imagine standing in a warm room while snow falls outside the windows. From inside, you can map the furniture and measure the temperature and learn the rules of the room with great precision. But no matter how clever you are, you cannot directly sample the storm without crossing the glass. The window is not evil. It is simply a boundary that defines what kinds of questions can be answered from where you stand. In the black hole universe thought experiment, our cosmic horizon becomes that window. We do not see an edge because the boundary is not presented as a cliff. It is presented as a limit of contact, a limit of messages that can arrive. Now consider a second image. Picture a whirlpool in a river. From far away, the water seems ordinary, flowing as it always has. But as you approach the center, the flow tightens and the surface becomes strange and glossy and fast. If you drop a leaf near the whirlpool, it circles and then vanishes into the unseen depth. The leaf does not know the river is still there beyond the spiral. It only knows the curve it can feel. Our universe might be like that leaf, tracing graceful arcs inside a geometry we cannot step outside to view. Albert Einstein gave us the language that made black holes conceivable, and he also left us a quote that feels like a lantern for this discussion. The most incomprehensible thing about the universe is that it is comprehensible. I hear humility in that line. The recognition that our equations are astonishingly successful, and yet our success does not automatically grant us the full story of what we are inside. The black hole universe idea stands on that same threshold. It uses our comprehension to point toward the possibility that comprehension has a horizon too. You asked for examples that make this easier to see in the mind. So here is one more that I love because it is tender and domestic. Imagine a child inside a vast cathedral at night. The child holds a candle and sees pillars and arches and paintings within the small circle of flame. The child might build a perfect theory of the cathedral within that circle and still never realize there is a roof far above with carvings lost in shadow. The candlelight does not lie. It simply has a boundary. In cosmology, our candlelight is the information carried by photons and neutrinos and gravitational waves, the messengers that travel to us across the abyss. The black hole hypothesis asks whether the roof of the cathedral might not merely be far away, but structurally unreachable from inside the nave. This is where the story becomes emotionally charged for me, because it is not only a question about distant physics, it is a question about human limits. Carl Sagan offered a sentence that has comforted millions and also sharpened their longing. Somewhere something incredible is waiting to be known. The black hole universe idea takes that longing and gives it a darker shade. It suggests that something incredible may be waiting not just beyond our current instruments, but beyond our category of access. And that is both haunting and strangely liberating. Because, if the ultimate boundary cannot be crossed, then curiosity becomes less like conquest and more like reverence. At the heart of this hypothesis sits a puzzle that feels almost mythic: the problem of information. We believe that the universe keeps its accounts, that nothing truly vanishes from the ledger of reality. Yet black holes seem to shred identity and erase history behind the event horizon. This conflict is not a side note. It is a crack in the foundation that physicists have stared into for decades. Here the holographic principle enters like a whisper from the edge of a dream. It suggests that what happens inside might be written on the surface, like an ancient seal pressed into wax. The surface becomes an archive, a cosmic skin that remembers what the interior cannot reveal directly. When you let that idea settle, it changes how you look at everything, even at yourself. If reality can be described as information arranged in patterns, then matter becomes a kind of sentence, and energy becomes a kind of grammar. In that view, a star is not only a furnace, it is a paragraph of physical law reading itself aloud in light. And a human life becomes not only a biological accident, but a brief knot of awareness tied into the larger tapestry of encoded order. That does not prove anything about being inside a black hole, but it makes the idea feel less like science fiction and more like a serious meditation on what it means for the universe to be knowable at all. So how does Big Bang fit into this darker poetry? This possibility that what we call a beginning might be the inside view of something collapsing elsewhere. Imagine a massive star in apparent reality collapsing under its own gravity, forming an event horizon that seals off a region of space-time from the outside world. From the outside, it looks like loss and swallowing. From the inside, the mathematics can look like expansion and unfolding. The same boundary that appears as a point of no return from one perspective might appear as a first dawn from another. It is a perspective trick written into the geometry of existence itself. Here is a simple way to feel this in the gut. Think of a seed in soil. From above ground, the seed seems buried and gone, pressed into darkness. From within the seed, the darkness is not an end. It is pressure and warmth and silence that enables a new structure to form. That metaphor can be dangerous if we treat it as evidence. But as a picture, it helps us hold the emotional shape of the question. Could a black hole be not only a mouth but also a womb? Could collapse and creation be the same event viewed from opposite shores? If you want more solidity than metaphor provides, then we can lean on what science actually touches. We have seen the shadow of a black hole, not with eyes, but with a planet-sized instrument and years of careful reconstruction. We have listened to the ringing of space-time when black holes merge, a soundless music translated into data. These are not myths, they are measurements. And yet every measurement stops at the horizon of access. The event horizon remains a kind of censorship imposed by nature, not malicious, simply absolute in our current understanding. That is why the hypothesis remains controversial and why it must be held with restraint. Many physicists will tell you that the universe does not behave like the interior of an ordinary black hole. They will note that our cosmos looks remarkably uniform on the largest scales and does not present an obvious center that everything falls toward. They will point out that in a typical black hole, gravity dominates ruthlessly, while our universe contains a strange repulsive effect we call dark energy that drives accelerated expansion. Those criticisms matter. They are part of the honesty of science. The most responsible way to approach this idea is not to declare victory, but to recognize it as a sharpening stone for deeper questions about horizons and information and beginnings. Roger Penrose once said something that fits this mood of careful awe. The laws of physics are not merely a description of the world. They are what the world is. If that is even partly true, then the black hole universe hypothesis is not a wild distraction. It is an attempt to read the laws more literally and more courageously. It asks whether the geometry that governs black holes might also govern the cosmos itself, on the grandest scale. It asks whether our notion of a singular beginning is a human preference for tidy narratives, and whether reality may instead be layered and nested in ways that our language struggles to hold. Now let us bring in the invisible giants that haunt modern cosmology: dark matter and dark energy. Together they make up most of the universe, and yet they do not glow in any telescope the way ordinary atoms do. They are like the wind in tall grass, known by their effects and never by their face. If our universe were inside a larger structure than one, might wonder whether these invisible influences are fingerprints of that larger context. Perhaps dark energy is not an exotic substance at all, but a boundary effect, a pressure of geometry speaking through the fabric of space-time. Again, this is not proof. It is a way to keep the mind flexible when the data refuses to fit our simplest stories. There is another reason this idea grips people, and it has nothing to do with equations. It touches a deep human intuition that we are inside something and that the inside has rules we did not choose. Long before physics spoke of horizons and singularities, our myths spoke of veils and thresholds and hidden oceans above the sky. I do not cite that as validation of modern theory. I mention it because it reveals a continuity in the human imagination. We have always sensed that reality has an outer skin and that our everyday world is only the inner chamber of a much larger temple. Modern physics does not confirm the old stories, but it sometimes returns us to the same emotional terrain. The feeling of standing before a sealed door with symbols we almost understand. What I take from this is a personal lesson about humility and courage. Humility because the universe may never yield a complete picture to creatures embedded inside it. Courage because our limitations do not cancel our responsibility to keep asking better questions. If the cosmos truly began in a singular event, then our task is to understand it without shrinking it into a slogan. If the cosmos instead emerged from the interior of a black hole in apparent reality, then our task is the same: to learn what can be learned and to honor what cannot. In both cases, the moral is not despair. The moral is wonder disciplined by honesty. Let me offer one final image to carry with you. Imagine the universe as a vast breathing creature of light and gravity, not a machine of cold parts. Galaxies drift like slow thoughts across its mind. Black holes pulse like deep hearts hidden in the dark. And we are tiny sparks of awareness moving through that immense interior, measuring and listening and building meaning from the faintest signals. If we are inside a black hole, then the black hole is not only outside us, it is the stage on which every human story has ever played. If we are not inside a black hole, then the hypothesis still serves a purpose. It reminds us that the universe is not obligated to match our first explanations. Neil deGrasse Tyson once said something that feels like the right closing breath for a journey like this. We are part of this universe. We are in this universe. But perhaps more important, the universe is in us. Whether our cosmos is a free expanse or the interior of a larger darkness, that sentiment holds. The universe becomes aware through our questions, and our questions become more beautiful when we admit how much we do not know. So here is my invitation to you. If you had to choose right now based on intuition alone, not certainty, not fear, not fashionable opinion, what would you say? Is the Big Bang the first heartbeat of everything, or the aftershock of a collapse beyond our horizon? Tell me in the comments what image your mind returns to. The candle in the cathedral, the seed in the factor soil, or the window looking out onto a storm you cannot touch. And stay with me, because the next step is to follow that question deeper, into the place where beginnings blur into boundaries, and where the universe may be hiding its oldest truth in plain sight. What if the most terrifying monster in the universe was never a monster at all, but a mirror that has been waiting for us to look into it? For a long time, black holes lived only in the cold palace of mathematics, like strange beasts drawn in chalk on the blackboard, beautiful and impossible at the same time. They were treated as tricks of equations, as if nature would never dare to build something so extreme, something that could swallow light itself and leave nothing but silence behind. And yet history has a way of humbling our certainty, because the universe does not ask what we find reasonable. It simply is. The turning point came when general relativity changed the language of gravity, and with it changed the shape of our imagination. Gravity was no longer a simple pull through empty space. No invisible rope, tugging at planets and stars. It became geometry, a living curvature in the fabric of reality. John Wheeler captured this with a line that still feels like poetry disguised as physics. Space-time tells matter how to move, matter tells space-time how to curve. In that single sentence, the cosmos becomes intimate, almost personal. Matter is not just stuff floating in a void. It is a sculptor. Space-time is not a passive stage. It is a responsive sea. To picture it in your mind without equations, imagine an endless dark ocean made of space itself. Place a star into that ocean, and it does not merely sit there. It presses down, and the ocean forms a slope around it. Now every passing planet is like a leaf caught on that slope, drifting along the curves because the water beneath it is tilted. This is the sweetness and the terror of relativity, because it means the universe is not rigid. What if the most terrifying monster in the universe was never a monster at all, but a mirror that has been waiting for us to look into it? For a long time, black holes lived only in the cold palace of mathematics, like strange beasts drawn in chalk on the blackboard, beautiful and impossible at the same time. They were treated as tricks of equations, as if nature would never dare to build something so extreme, something that could swallow light itself and leave nothing but silence behind. And yet history has a way of humbling our certainty, because the universe does not ask what we find reasonable. It simply is. The turning point came when general relativity changed the language of gravity, and with it changed the shape of our imagination. Gravity was no longer a simple pull through empty space. No invisible rope tugging at planets and stars. It became geometry, a living curvature in the fabric of reality. John Wheeler captured this with a line that still feels like poetry disguised as physics. Space-time tells matter how to move. Matter tells space-time how to curve. In that single sentence, the cosmos becomes intimate, almost personal. Matter is not just stuff floating in a void. It is a sculptor. Space-time is not a passive stage. It is a responsive sea. To picture it without equations, imagine an endless dark ocean made of space itself. Place a star into that ocean, and it does not merely sit there. It presses down, and the ocean forms a slope around it. Now every passing planet is like a leaf caught on that slope, drifting along curves because the water beneath it is tilted. We call it an orbit, but in this view it is closer to a kind of falling that never ends. Now take that image and keep turning the dial of mass upward, until the slope becomes so steep that even light cannot climb out. That is the emotional doorway into the idea of an event horizon. People often imagine it as a wall, a surface you crash into. But it is not a wall at all. It is a boundary of fate. A line in space-time where escape stops being a possibility. From the outside, it looks like a threshold of darkness. From the inside, it is simply the moment your future becomes unavoidable. Here is a simple example to make it feel real in your bones. Think of standing in a river at night. the current is gentle at your ankles. You can step back to shore with ease. Walk deeper, and the current presses at your knees, then at your waist. At some point you reach a place where the current is stronger than your muscles, and the river decides for you. You may still be upright for a heartbeat, but the outcome is settled. The event horizon is like that place in the river, except the current is gravity itself. Not a force pulling you through space, but the slope of space-time turning so steep that every path forward points inward. And then there is time. The most haunting part is not that black holes trap light, but that they bend the meaning of now. Near-intense gravity clocks tick differently, not as a metaphor, but as a physical fact. If you could hover near a black hole and look outward, you would watch the universe hurry while you remain in slow motion. That sounds like fantasy until you remember that even around Earth we measure tiny differences in clock rates because gravity is slightly stronger at the surface than in orbit. Nature is quietly telling us that time is not a universal drumbeat. It is a local weather pattern. This is where the story becomes almost tender, because the equations become a kind of lullaby of inevitability. As mass grows extreme, space folds inward, time slows down, and the event horizon appears not as a thing but as a limit on knowledge. That last point matters, because the horizon is not only a physical boundary, it is an epistemic one. It is a reminder that there are regions of reality where our questions may arrive but our answers cannot return. Stephen Hawking once offered a sentence that feels like a warning and a wink at the same time. Black holes ain't as black as they are painted. He was pointing toward a deeper truth, that black holes may leak subtle radiation, that even the darkest objects may have a kind of whispering edge. Whether or not we ever measure that whisper directly in the sky, the philosophical impact is immediate. It suggests that the universe is more nuanced than our fears. What if the most terrifying monster in the universe was never a monster at all, but a mirror that has been waiting for us to look into it? For a long time, black holes lived only in the cold palace of mathematics, like strange beasts drawn in chalk on the blackboard, beautiful and impossible at the same time. They were treated as tricks of equations, as if nature would never dare to build something so extreme, something that could swallow light itself and leave nothing but silence behind. And yet history has a way of humbling our certainty, because the universe does not ask what we find reasonable. It simply is. The turning point came when general relativity changed the language of gravity, and with it changed the shape of our imagination. Gravity was no longer a simple pull through empty space, no invisible rope tugging at planets and stars. It became geometry, a living curvature in the fabric of reality. John Wheeler captured this with a line that still feels like poetry disguised as physics. Space-time tells matter how to move. Matter tells space-time how to curve. In that single sentence, the cosmos becomes intimate, almost personal. Matter is not just stuff floating in a void. It is a sculptor. Space-time is not a passive stage. It is a responsive sea. To picture it without equations, imagine an endless dark ocean made of space itself. Place a star into that ocean, and it does not merely sit there. It presses down, and the ocean forms a slope around it. Now every passing planet is like a leaf caught on that slope, drifting along curves because the water beneath it is tilted. We call it an orbit, but in this view it is closer to a kind of falling that never ends. Now take that image and keep turning the dial of mass upward, until the slope becomes so steep that even light cannot climb out. That is the emotional doorway into the idea of an event horizon. People often imagine it as a wall, a surface you crash into. But it is not a wall at all. It is a boundary of fate. A line in space-time where escape stops being a possibility. From the outside it looks like a threshold of darkness. From the inside it is simply the moment your future becomes unavoidable. Here is a simple example to make it feel real in your bones. Think of standing in a river at night. The current is gentle at your ankles. You can step back to shore with ease. Walk deeper and the current presses at your knees, then at your waist. At some point you reach a place where the current is stronger than your muscles, and the river decides for you. You may still be upright for a heartbeat, but the outcome is settled. The event horizon is like that place in the river, except the current is gravity itself. Not a force pulling you through space, but the slope of space-time turning so steep that every path forward points inward. And then there is time. The most haunting part is not that black holes trap light, but that they bend the meaning of now. Near intense gravity clocks tick differently, not as a metaphor, but as a physical fact. If you could hover near a black hole and look outward, you would watch the universe hurry while you remain in slow motion. That sounds like fantasy until you remember that even around Earth we measure tiny differences in clock rates because gravity is slightly stronger at the surface than in orbit. Nature is quietly telling us that time is not a universal drumbeat. It is a local weather pattern. This is where the story becomes almost tender, because the equations become a kind of lullaby of inevitability. As mass grows extreme, space folds inward, time slows down, and the event horizon appears not as a thing but as a limit on knowledge. That last point matters, because the horizon is not only a physical boundary, it is an epistemic one. It is a reminder that there are regions of reality where our questions may arrive but our answers cannot return. Stephen Hawking once offered a sentence that feels like a warning and a wink at the same time. Black holes ain't as black as they are painted. He was pointing toward a deeper truth, that black holes may leak subtle radiation, that even the darkest objects may have a kind of whispering edge. Whether or not we ever measure that whisper directly in the sky, the philosophical impact is immediate. It suggests that the universe is more nuanced than our fears. Kip Thorne went further in spirit when he described black holes as among the simplest objects in the cosmos. Kip Thorne went further in spirit when he described black holes as among the simplest objects in the cosmos. Objects that can be characterized by only a few numbers, and yet unleash the deepest questions we have about reality. That contrast is the strange beauty of the subject. The universe builds something almost minimal in description, and then hides inside it the maximum of mystery. To make this less abstract, picture two very different black holes. One is small, born from a dying star. Have you ever wondered what it would feel like if time itself stopped trusting you? As if the universe quietly changed the rules while you were still counting seconds. Imagine drifting toward a black hole the way a leaf drifts toward a whirlpool at dusk. Slow at first, almost tender, as though nothing dramatic is happening at all. Your instruments are calm, your heartbeat is steady, and the stars ahead look like ordinary stars. But then the clock on your wrist begins to behave like a nervous liar. It still ticks. It still sings its little mechanical song. But its promise no longer matches reality. You glance outward and you see something that should not be possible. The outside universe seems to stiffen, as if the cosmos has become a statue caught mid-breath. Yet you keep moving. You keep falling. And inside your own body, time remains intimate and ordinary. This is the first betrayal, the one that feels personal, because it is not just physics anymore. It is perception, memory, and the fragile story you call now. The strange beauty of this idea is that it is not a poet's fantasy. It is the consequence of our best description of gravity. General relativity does not treat time as a rigid river flowing the same for everyone. It treats time as something that can be stretched, thinned, slowed, and folded by mass and motion. That is why the line in your script hits so hard. With an observer outside, everything appears to freeze. With the one falling in, time continues without mercy. We are not talking about a clever camera trick. We are talking about a real disagreement between viewpoints that the universe allows at the deepest level. Stephen Hawking gave people a simple image to hold on to when describing the event horizon. He said falling through it is like going over Niagara Falls in a canoe. Above the falls you can still paddle away. Over the edge, you are lost. That metaphor matters because it captures the emotional geometry of the boundary, not just the mathematical one. There is a moment when escape stops being a matter of effort and becomes a matter of impossibility. And with impossibility comes a new kind of time. Now let me make this vivid with something closer to home. You do not need a black hole to experience time behaving differently. You only need gravity and speed. The satellites that run GPS carry clocks that would drift if we pretended time was universal. Because up there gravity is weaker and they are moving fast. Engineers have to correct for relativity or your map would slowly lose its mind. In other words, the phone in your hand works because time is already flexible. We have built a civilization that depends on time not being absolute, even if most people never feel it in their bones. A black hole is simply where that flexibility becomes extreme enough to feel like sorcery. Kip Thorne put it bluntly when he wrote, "Black holes are made from warped space and warped time. Nothing else." That sentence is almost frightening in its simplicity, because it removes the monster costume and reveals the structure underneath. If a black hole is mostly geometry, then what you are falling into is not an object in space, but a reshaping of what space and time mean in the first place. So return to the scene of the fall. From far away, an outside observer watches you approach the event horizon and thinks you never quite cross it, because the light carrying your final moments takes longer and longer to climb out of the gravitational well. Your image reddens, fades, stretches into a slow goodbye. The outside universe sees a kind of eternal hesitation, a person held at the edge of the known world like a note that never resolves. But from your perspective, you cross in finite time, without fireworks, without a signpost, without the universe announcing the transition. The boundary is not a wall you hit. It is a line you step across, while the universe keeps its secrets. Then comes the part your script says in one haunting breath. Inside, direction itself begins to vanish. The future becomes a place you cannot avoid. This is not just poetic language. It is the logic of curved space-time near the center. In normal life, you can choose to stand still, or turn around or walk away. The future is an idea, and space is where you move. Near a black hole's interior, those roles twist. The way forward becomes as compulsory as tomorrow. You do not fall toward the singularity the way you fall toward a cliff. You fall toward it the way you fall toward next week. That is the terror and the elegance of the math. To help the mind grasp it, picture a river at night, wide and black and glossy. Upstream you can swim against the current if you are strong enough. Closer to the waterfall, the current accelerates until swimming becomes meaningless. Not because you are weak, but because the river has changed what effort can accomplish. The event horizon is where the current becomes equal to the fastest thing that can carry information, light itself. Past that point, the river does not merely pull you. It defines your only direction. Now we arrive at the question that turns this from a black hole story into a universe story. If our cosmos also has a horizon beyond which we cannot see, if our knowledge also stops at a boundary defined by the speed of light and the age of time, then what does that say about the flow we call history? We talk about the observable universe as if it were a practical limit, a fog line on a distant road. But what if it is more like an undying event horizon in spirit? Not exactly the same physics, yet the same philosophical wound. A boundary that tells us there are regions of reality that will never send their stories to our eyes. When you really sit with that, time starts to feel less like a universal metronome and more like a perspective-dependent melody. There is your time, your heartbeat and your aging, and your private stream of moments. There is cosmic time measured by expansion and background radiation and the slow cooling of the whole sky. And there may be deeper clocks we do not yet know how to name. Clocks written into structure itself. That is where your final question lands with such force. If the universe operates in a way that resembles the interior logic of a black hole, is the time we feel merely a consequence of a deeper architecture? I will add a personal thought here as someone who has spent years watching science change the meaning of ordinary words. When I was younger, time felt like a straight road, dependable and shared by everyone. But the closer you look at the universe, the more time reveals itself as something the cosmos negotiates rather than obeys. That realization does not make life colder. It makes it more sacred. Because if time is not a single river but a landscape of currents, then every moment you experience is the result of an invisible choreography of gravity and motion and cosmic history. Carl Sagan once gave us a line that still feels like a candle in a dark observatory. The cosmos is within us. We are made of star stuff. We are a way for the universe to know itself. I think of that when imagining a traveler near a black hole, a small, conscious creature inside a vast curvature of space-time. Even there, where clocks disagree and horizons erase return paths, awareness still burns. And that might be the strangest part of all. Not that time can slow, but that something inside us can notice it slowing. So what is the lesson you can offer your viewers without preaching, without turning wonder into a sermon? It is this: the universe does not owe us an intuitive reality. It gives us a reality we can test and measure and sometimes barely tolerate. The black hole teaches humility because it shows that the most familiar thing in our lives, the flow of time itself, can become relative when the structure deepens. And it teaches courage because it suggests that confusion is not failure. Confusion is the edge of a map being drawn in real time. If you want one more image that people can feel, think of two friends trying to stay in sync on a long road trip at night. One drives through flat plains under calm skies. The other drives into mountains where the road twists and the air thins and the gravity of the landscape changes the rhythm of every mile. They both move forward. They both arrive older. Yet their stories of the same night differ in texture and duration. That is relativity in miniature. A hint of the cosmic truth that there is no single stopwatch for existence. And now I will end exactly where your hook wants to leave the audience. If the falling observer carries time inward, while the outside observer sees a slow, freezing goodbye, then time is not merely something that happens. Time is something the universe permits, depending on where you stand and how you move and what holds you in its gravity. So look at the sky tonight and ask yourself gently, what if our sense of past and future is not fundamental, but emergent, a surface symptom of a deeper cosmic structure? And if that possibility makes your chest feel tight with awe or fear or quiet peace, tell me in the comments what you think time really is. A river, a labyrinth, a memory machine, or a horizon we are always approaching. What if the most terrifying place in the cosmos is not a monster that destroys everything, but a mirror that remembers everything? You and I were raised on a promise that feels almost moral in its certainty, that information cannot truly die. In physics, this is not poetry. It is a backbone principle that says the universe keeps its receipts. Yet a black hole looks like the perfect thief, swallowing stars as if they were sparks of dust, erasing names and histories in a silence so complete that even light cannot testify. This is where the story becomes more than astronomy. It becomes a confrontation with the idea of loss itself. Because if a black hole can delete information, then the universe can forget. And if the universe can forget, then our deepest physical laws are not laws at all. Stephen Hawking once shook the world by arguing that black holes could make information disappear from our universe forever. Leonard Susskind pushed back with equal conviction, insisting that nature does not permit such a vanishing act. And John Wheeler gave us a haunting phrase that still echoes through modern physics. It from bit. The suggestion that reality is stitched from information itself. Jacob Bekenstein gave the first great clue that something uncanny was happening at the edge, when he found that a black hole has entropy, and that this entropy scales with area, not volume. Gerard, Hooft and Susskind carried that clue into an idea so strange it almost sounds spiritual, that the information of a region of space might be encoded on its boundary, like a cosmic hologram. When you hold these voices together, Hawking's provocation, Bekenstein's measure, Wheeler's intuition, and Suskind's refusal to accept oblivion, you begin to feel the shape of the paradox. We stand between two truths that both feel unavoidable. Quantum mechanics says information is never destroyed, and classical black holes seem to destroy it completely. The tension is not academic. It is visceral, because it asks a simple question in a terrifying way. Where does reality store its memory? To make this tangible, imagine you burn a book in a fireplace. The pages vanish. The ink curls into smoke. The story seems lost. But physics whispers that the information is still there, not as readable sentences, but as an exquisitely complicated pattern in the heat, the ash, the motion of air molecules rising and colliding and scattering through the room. In principle, If you knew every microscopic detail with impossible precision, you could run the universe backward and reconstruct the book. That is what it means for information to be conserved. Now take the same book and drop it toward a black hole. Far away you watch it fall and you expect a dramatic ending. But something eerily different happens. As the book approaches the event horizon, it appears to slow, to dim, to redden, shift, to redden, as if the universe is gently turning the lights down on it. From your viewpoint, it never quite crosses the boundary. It becomes a fading photograph pinned at the edge of night. Yet the black hole grows as if it did swallow the book. Mass added. Gravity deepened. So the book both does and does not cross depending on where you stand. This is the first hint that black holes force us to confront not only matter, but perspective. To the falling book, the crossing is ordinary and inevitable. The horizon is not a wall you crash into. It is a place you pass without noticing at the moment of passage. And then there is the deeper horror. Once inside, there is no turning around, because every future path points inward toward the unknown. Now comes the question that makes physicists lose sleep. If that book eventually disappears behind the horizon, and the black hole later evaporates through Hawking radiation, what carries the book's information back out? Hawking radiation, in its simplest description, is a whisper from quantum uncertainty at the edge. A faint leak from a place that should not leak at all. Over unimaginable times, the leak drains the black hole until nothing remains but emptiness and a memory problem. If the radiation is purely thermal and featureless, then the information is gone, and the universe has committed the one crime quantum theory forbids. This is why the information paradox is not a niche puzzle. It is a test of whether reality has integrity. And here is where the boundary becomes the star of the story. The event horizon is not a material shell, yet it behaves like a ledger. Bekenstein showed that the entropy of a black hole is proportional to the area of that horizon, not the volume inside. That single fact is like a crack of lightning across a calm sea, because it hints that the universe counts information on surfaces, not in rooms. If you want an everyday picture for this, think of a hard drive. You might assume the data lives in the depth of the device, but what matters is how it is encoded across a structured layer. Or think of a vinyl record. Music is not floating in the air inside the disc. It is etched onto a surface pattern so fine that a needle can translate it back into sound. The holographic idea suggests the event horizon is like that. A surface where the universe engraves what fell in. So when you ask where reality stores its memory, one answer becomes almost unavoidable. Not deep in the belly of the black hole, but on its skin. A skin made of mathematics, thermodynamics, and quantum law. In this view, the black hole is not a shredder. It is an encoder. It scrambles what you drop in beyond recognition, but it does not erase it. Like a message put through a cipher, the meaning is hidden, not destroyed. Now picture a more vivid example. Imagine you toss a single snowflake into a raging waterfall. The snowflake is gone to your eyes, but every molecule of water remembers the collision, the momentum exchange, the microscopic ripples that spread outward. The information is dispersed into complexity, not erased from existence. A black hole may be the ultimate waterfall, except its surface is where the ripples are recorded. Of course, there is a sting in the tail, because even if the information is preserved, it may be preserved in a way we cannot decode. That is the emotional weight of the paradox. The universe might be faithful, yet still unreadable. It is like believing every moment of your life has been saved perfectly in an archive. But the archive is written in a language no mind can speak. It is memory without access, truth without retrieval. This is where my own view becomes less like a textbook and more like a meditation. The black hole information problem teaches humility in a uniquely cosmic way, not by telling us we know nothing, but by showing us what knowledge may actually be. We often imagine the universe stores facts like a library stores books, each page neat and accessible. But black holes suggest a different kind of storage, a storage of relationships, correlations, entanglements. In that light, the question changes subtly. It is no longer simply whether information is lost. It becomes whether meaning can survive scrambling. When I think about the horizon as a boundary of memory, I cannot help seeing a metaphor for our own lives. We live inside a limited window of perception, a small cone of attention, and we mistake that for the whole of reality. Beyond our senses there is a larger ledger. Beyond our instruments, a deeper encoding. The universe may be telling us, gently and relentlessly, that the deepest truths are not always visible truths. And now we arrive at the final question that ties everything together. If information is written on the edge of a black hole, what does that imply about our universe itself? Because we also live behind a horizon, the cosmic horizon, the limit beyond which light has not had time to reach us. We too are surrounded by a boundary of observation, an edge that defines what can be known from where we stand. It is hard not to wonder whether the universe behaves like a black hole in disguise, whether reality itself is an interior experience, projected from an unseen surface. The practical lesson I take from all this is strangely comforting. Not because it resolves the mystery, but because it reframes it. The cosmos may not be a place where things vanish without trace. It may be a place where nothing is truly thrown away, only transformed beyond recognition. That does not mean we should drift into fantasy. It means we should respect the difference between what is lost and what is merely inaccessible. It also suggests a quiet ethic for living. If the universe keeps a perfect account of interactions, then every small act matters in ways we cannot measure. Not as moral bookkeeping in the human sense, but as physical imprint, as causal thread. So when you hear the claim that black holes erase everything, hear the deeper counterclaim alongside it. That the event horizon may be a kind of cosmic memory foam, registering every fall, every whisper of energy, every identity reduced into pattern. The terror is that we cannot read it. The wonder is that it might exist at all. And that is the promise I leave you with. The paradox is not a dead end. It is a doorway to a deeper physics we have not yet earned. If you had to guess right now, where do you think the universe hides its memory? In the depths? Or on the edge? And what would it mean for us if reality is written on a boundary we can never touch? What if the deepest secret of a black hole is not how it destroys matter but how it stores meaning? What if the universe is not a vast container we live inside, but a message written on an edge we can never touch? There is a moment in modern physics when the story turns strange in the quietest possible way, not with an explosion or a telescope image, but with a simple accounting problem about entropy. Entropy is a word that sounds like dust on an abandoned shelf. Yet it is one of the most honest measures we have of reality. It counts possibilities. It counts hidden arrangements. It counts how many different ways the same world can be arranged behind the curtain of what we see. And then black holes arrive like a silence that refuses to stay. Poetic. Because they demand a number. Jacob Bekenstein looked into that darkness and made a statement so clean it still feels like a blade of ice. The entropy of a black hole is proportional to the area of its event horizon. Not its volume, not the space inside, but the surface. Stephen Hawking followed and gave the darkness a temperature, a faint breath of radiation leaking away over unimaginable time. He once said that black holes are not completely black. The universe listened, because that single idea turned a mythic abyss into a thermodynamic object that can glow, however faintly. Then Leonard Susskind took the implication and said what many were afraid to say out loud, that the world might be a hologram. And Gerard T. Hooft sharpened the same intuition into a principle that refuses to go away. That the information content of a region of space can be described by degrees of freedom living on its boundary. Pause there, because this is where the mind begins to tilt. We grew up believing that if you want to store more information, you need more room inside the box. A bigger attic, a larger library, more shelves. But black hole entropy laughs at that intuition without making a sound. It says the library is not in the building. The library is on the walls. It is as if the universe is telling us that depth is an illusion we have learned to trust because it is useful for survival, not because it is fundamental. Imagine a simple scene you can hold in your hands: a small hard drive and a large empty warehouse. Your instinct says the warehouse can contain more stuff, more storage, more secrets. Yet, the black hole result is like discovering that the warehouse stores its entire inventory on the paint of its outer door. Or think of a vinyl record, a flat black disc with microscopic grooves. When the needle touches the surface, a whole orchestra emerges. Violins and thunder, and grief and joy. The music is not hidden in the air inside the room. It is written in patterns on a boundary that looks almost featureless until you learn how to read it. That is the emotional shock of the holographic idea. It takes the richest three-dimensional experience you have and suggests it could be encoded on something flatter than your intuition can accept. Now bring that back to a black hole, the darkest object you can imagine. It has an edge that is not a surface you can stand on, yet it behaves like the ultimate surface in physics. Everything that falls in seems lost to us forever, and yet quantum mechanics insists the information must remain. The holographic principle offers a strange kind of mercy. It suggests the information is not destroyed. It is smeared across the horizon in a form we do not yet know how to decode. Like ash pressed into a fingerprint along the rim of the abyss. At this point the question becomes too beautiful to ignore. If a black hole can encode a three-dimensional interior on a two-dimensional boundary, then what about the largest system we know, the universe itself? Could our entire cosmos be a kind of projection, not floating freely in infinite space, but arising from information written on a cosmic edge? Not inside the universe, but on the rim of what we can never see beyond. This is where I like to slow down and let the imagery do its work. Because the universe is not only equations, it is also atmosphere. Picture a winter night, far from city lights. where the sky looks like a deep well of velvet and frost. You look up and feel distance as if it were a physical thing, a cathedral of blackness punctured by cold stars. Now imagine that what you call depth is a perceptual gift rather than an ontological truth, that the cathedral is a kind of illusion produced by a boundary you will never reach. It would be like living inside a planetarium, where the dome is not just a screen but the true ledger of reality, and everything you experience is the light thrown inward from that hidden accounting. There is a reason this idea refuses to stay in the realm of metaphors, because it connects to real mathematics that has been startlingly productive. Juan Maldacena offered a bridge known as AD-CFT correspondence, a way of showing that a theory with gravity in one space can be equivalent to a theory without gravity on a boundary of lower dimension. You do not need to love the technicalities to feel the philosophical tremor. If gravity and space-time can emerge from boundary information in a controlled mathematical setting, then space-time itself begins to look less like a stage and more like a story being computed from something deeper. And that brings us to the most human part of the whole discussion, because the holographic principle is not only about black holes, it is about humility. We are a species that mistakes the map for the territory when the map works well enough to get us through the day. We assume the world is made of what appears in front of us. Objects in space, time flowing like a river. But the holographic hint says you may be living inside an interpretation layer, a beautifully coherent hallucination generated by deeper rules we are only beginning to glimpse. To make it feel less abstract, try one more analogy that is almost embarrassingly ordinary. Think of a credit card strip or a QR code. It looks like a flat pattern, and yet it can represent your name, your access, your identity in a system far larger than the card itself. The meaning is not in the thickness of the plastic. It is in the arrangement on the surface and the rules for decoding it. Or think of a seed, a small boundary of skin holding a future forest in compressed instructions. The forest is not already inside as miniature trees. It is encoded as possibility in a pattern that unfolds when conditions allow it. In that sense, the holographic idea is like suggesting the universe is an unfolding from a boundary code, a cosmic seed whose surface contains the rules of its own expansion into experience. Now I want to be careful and honest, because a good science communicator does not sell certainty where none exists. The holographic principle is not a proven description of our universe in the everyday observational sense. It is a guiding idea supported by deep consistency checks and successful frameworks in certain settings. There are debates about how directly it applies to the cosmos we inhabit, with its accelerated expansion and its specific geometry. But the reason it matters is not because it is already the final answer. It matters because it reshapes the kinds of questions we are brave enough to ask. And that is where the personal lesson arrives for me, quietly, like starlight that has traveled too long to still carry the heat of its origin. We often imagine knowledge as conquest, as if we can force the universe to reveal itself by building bigger machines and louder theories. But black holes teach a different posture, a posture of listening to limits. The event horizon is not only a boundary in space, it is a boundary in method. It tells us that some truths might be encoded in ways we cannot directly inspect from where we stand, that the universe may be legible only indirectly, through shadows and echoes and conservation laws that refuse to be violated. So when I hear the line that the world might be written on its edge, I do not hear despair. I hear a kind of invitation. If reality is a projection from a boundary we cannot see, then our task is not to panic about our smallness. It is to refine our questions until they become precise enough to catch what the boundary is whispering through the behavior of the inside. It becomes an act of patience, and in a strange way, an act of reverence. Because consider what this does to the way you look at your own life, your memories, your grief, your love. If information is never lost in the deepest physics sense, if the universe is capable of storing the story of everything that falls into darkness, then the cosmos begins to resemble a vast remembering rather than a vast forgetting. Even if that remembering is encoded in a language of surfaces and quantum correlations that we cannot yet translate. The poetic danger here is obvious: to turn a scientific idea into a spiritual certainty. I will not do that. But I will allow the emotional truth to stand where it belongs, on the edge of what we know. When the best minds in physics suggest that the universe might be describable from its boundary, they are not selling magic. They are following the evidence of consistency that black holes forced upon us. The darkness compelled a new humility in the light, and that humility is one of the most trustworthy moods science can offer. So here is the question I keep returning to in the quiet moments after the equations fade. If our three-dimensional world is a projection, then what is doing the projecting? What is the boundary really made of? Not material but rule. Not substance but structure. And if we are indeed written on an edge, does that make our lives less real, or more astonishingly precise? The lesson I take is simple enough to carry into ordinary days. When reality reveals that it may be deeper than it looks, do not cling to appearances. Let curiosity become a practice, like breathing, like watching waves collapse and reform on a beaded shoreline at night. The universe may not be a room we occupy. It may be a story we are inside, written in a script along an unseen rim. And if that is even partly true, then every time we learn a new law of nature, we are not just collecting facts. We are learning to read the handwriting of the cosmos. What if the Big Bang was not a birth at all, but the sound a deeper universe makes when it falls into silence? I want you to picture this as simply as possible, because the idea is strange only until it becomes intimate. From the outside, the formation of a black hole looks like collapse, like a great star finally losing the argument with its own weight. Space folds in on itself. Light bends and fails to return, and a boundary appears where every path points inward. But from the inside, that same story could feel like something else entirely, not falling inward, but bursting outward. Not a funeral for a star, but an opening of a sky that never existed before. To make this feel real, imagine standing on a shoreline at night, watching a storm far out at sea. To you, the horizon is a clean line where the world ends. Yet you already know it is not the end of the ocean, only the end of your sight. The event horizon of a black hole is like that horizon, but not made of water and distance, made of gravity and time. Cross it, and the universe does not become empty. It becomes hidden. That is the first emotional punch of this idea, because it suggests that limits are not walls. They are veils. Einstein gave us the language that makes this possible to imagine, even if he himself disliked the implication. He taught us that gravity is not a pull in space, but the bending of space and time themselves. You can feel this with a simple image, the old rubber sheet metaphor. place a heavy ball on a stretched fabric, and the fabric curves. Smaller balls roll toward the dip not because they are being grabbed by invisible hands, but because the surface beneath them has changed shape. Now replace the fabric with reality itself, and replace the ball with a dying star. If the star is massive enough, the curve becomes so deep that there is a point where even light cannot climb out. That boundary is the event horizon. Now comes the twist that the mind resists at first. The same mathematics that describes collapse can also describe expansion. We often imagine Big Bang as a firework in empty darkness. But physics does not require an explosion into space. It can be the expansion of space itself. That is why this theory feels like poetry with equations behind it, because it asks you to swap the direction of the story without changing the rules of the story. From one viewpoint, a star collapses into a black hole. From another viewpoint, a universe begins to inflate and cool. One event, two experiences. If you want a more tangible analogy, think of a seed pressed hard into soil. From above the ground, it looks like burial, a small thing disappearing into darkness. But from within the seed, the pressure is not death. It is the condition for opening. The shell splits. The first pale root explores the unseen, and suddenly the world is not smaller. It is larger. Collapse and expansion are not always opposites. Sometimes they are the same motion told from different sides of a boundary. This is where the phrase Big Bang as the reversal of compression becomes more than a clever line. It becomes a serious invitation to rethink what beginnings are. Because when we say the universe began from an extremely dense state, we are already admitting that everything we see was once packed beyond imagination. If that packing occurred because matter fell into a black hole in a larger reality, then what we call the beginning could be the inside view of that fall. The idea grows even more unsettling when you remember the two horizons we carry in our modern cosmology: the event horizon of a black hole and the cosmic horizon of the observable universe. The cosmic horizon is not a physical edge either. It is a limit set by time and light. Light has only had so long to travel since the early hot epoch. So there are regions whose light has not reached us and may never reach us. We look out and see a boundary not because the universe stops there, but because our story stops there. In that sense, the cosmic horizon behaves like an event horizon for knowledge, a point beyond which we cannot receive messages. And that resemblance is exactly what makes some scientists wonder whether we are already living inside a larger gravitational boundary. Stephen Hawking once described black holes in a way that still feels like myth made scientific. He called them not eternal prisons, but objects that can slowly leak energy. His work on black hole radiation lit a candle in the darkest place imaginable, suggesting that even the blackest boundary is not perfectly sealed. And Leonard Susskind argued fiercely that information is not destroyed in black holes, that it is somehow preserved. The public remembers the drama of that debate, but the deeper meaning is almost spiritual, because it implies that the universe keeps a record of what happens even when it hides the stage. If information is not lost, then reality is not merely matter and motion. It is memory. From that line of thought comes the holographic principle. A name that sounds like science fiction and yet arises from sober mathematics. It suggests that what happens inside a region can be encoded on its boundary, like a three-dimensional scene written as information on a two-dimensional surface. If you have ever seen a hologram on a credit card, You know the magic is not in thickness. It is in pattern. Tilt it slightly and depth appears from a thin film. Now imagine that space-time itself could be like that. That what we call distance and volume might emerge from information stored on an edge we cannot touch. In this picture, the universe begins to feel less like a container and more like a song, where the melody you hear is not located inside the air. It is carried by the relationships between notes. Here is an example that can help the mind stay grounded, because it is easy to float away in abstraction. Imagine you are inside a vast domed planetarium, so perfect that you forget it is a dome. Stars are projected on the inner surface, and the illusion is complete. From the inside, you might assume the stars are infinitely far away, scattered through endless depth. But an outside observer knows the entire display is encoded on a curved surface. That is not proof of our reality being a projection, but it shows how easily depth can be experienced as real even when it is generated from a boundary. Now return to the core claim, that the event horizon of a black hole might act like a boundary between worlds. If a black hole exists in some higher dimensional space, then what we call our universe could be the interior region described in a different set of coordinates. What appears to the bay outside as collapse could appear to the inside as expansion. You can think of it like turning a glove inside out. The same object, a new orientation. The fabric does not change, but the viewpoint transforms everything you can see. Of course, a careful scientist must immediately ask, what would be different if this were true? That is where the idea becomes both fascinating and fragile. If we truly lived inside a black hole, would we see extreme time dilation everywhere? Would the universe have a center, pulling everything inward? Our cosmos appears remarkably uniform on the largest scales, with no obvious central point. That is one reason many physicists remain skeptical. And skepticism is not an enemy of wonder. It is the discipline that keeps wonder honest. Roger Penrose has often reminded us that the universe still holds deep puzzles about time, beginnings, and the nature of physical law. Alan Guth described inflation as a moment when the universe underwent an extraordinary expansion, smoothing and stretching space-time on unimaginable scales. Those are not endorsements of the black hole universe idea by themselves, but they show something important. Modern cosmology already accepts that our intuitive sense of size and time can fail spectacularly at the beginning. If the early universe can expand faster than ordinary imagination can track, then it is not absurd to ask whether that expansion could mirror processes near horizons. Here is another image to hold on to, simple enough to feel in your hands. Picture a sponge fully saturated with water, then squeezed hard in a fist. From the outside, the sponge is being compressed. Water is forced inward and outward at once. Now release the grip suddenly, and the sponge expands back. The same material, the same water, but a different phase of the story. In some speculative models, a true singularity might be avoided by quantum effects, replaced by a bounce. Compression reaches a limit, then geometry responds with expansion. Again, this is not a settled fact. It is an attempt to build a bridge between what relativity predicts and what quantum theory insists upon. Now consider why the horizon metaphor matters so much to the human heart. Because every civilization has had a horizon, a line beyond which gods and monsters were placed. Today our monsters are more elegant. They are equations and invisible boundaries. But the feeling is ancient. The ache of knowing there is more than we can see. When we say perhaps we do not see the edge of the universe because we have been inside it from the beginning, we are really saying something deeper. That our perspective might be trapped within a story that cannot read its own cover. And here is where I give you my personal view. Not as proof, but as a way of holding the meaning gently. I do not need this hypothesis to be literally true to feel its value. Because it teaches a discipline of humility, the kind that makes a person kinder and more awake. If the cosmos can contain horizons that no instrument can cross, then certainty is not the natural state of intelligence. Curiosity is. The universe does not owe us a complete map, but it does offer us clues. And we are built to follow clues. Think of the way an old telescope works. A simple tube of glass and patience. It cannot touch the stars, yet it changes the mind that looks through it. The black hole universe idea is like that. A conceptual telescope. It stretches the imagination to the point where it becomes a scientific instrument of its own. Even if later evidence proves the model wrong, the act of seriously entertaining it sharpens our sense of what questions matter. And what questions matter most here? Not only what happened at the beginning, but what a beginning even is. Not only whether horizons exist, but what they do to the creature who keeps walking toward them. If our universe is inside a black hole, then every black hole in our universe could be a seed of another universe. That image is both terrifying and beautiful. Terrifying because it makes our cosmos feel like a single chamber in an endless labyrinth. Beautiful because it makes creation feel ongoing, not a single ancient accident. To help you feel the scale of that thought, picture a winter orchard at night. Each tree holds countless seeds hidden in its fruit. The orchard is quiet, but it is not empty. It is packed with futures. In a similar way, black holes could be cosmic fruit, dark on the outside, yet holding the potential for new space-time on the inside. Again, this is speculative, but it gives the mind a place to stand. Now let us circle back to the original line, the one that feels like a key turning in a lock. From outside, black hole formation is collapse. From inside, it could be violent expansion. Big Bang in this view is not creation from nothing, but the inside face of compression reversing. The cosmic horizon reflects the event horizon, and our inability to see an edge may be because we are already within the boundary from the start. What lesson do I take from this as a storyteller of science? I take a lesson about perspective. The same reality can look like an ending from one side and a beginning from another. The same boundary can feel like a prison or a cradle depending on where you stand. And in daily life, this matters more than we think. Because there are horizons in us too. Limits of knowledge. Limits of certainty. Limits of control. When we hit them, we can call it failure, or we can call it an invitation to expand inwardly. The cosmos trains us in that choice. So here is the promise I leave you with. The value of this idea even before it is proven or disproven. It reminds us that reality may be deeper than our story about it. It reminds us that the universe may not be a flat timeline that begins and ends, but a layered process of transformation. It reminds us that the night sky is not only something to look at, it is something looking back through the mathematics we are slowly learning to read. And if you feel that quiet tremor in your chest right now, that mixture of awe and unease, that is exactly the correct response. Because the best ideas in cosmology do not simply give answers. They enlarge the soul of the question. What if the universe you have trusted your whole life is only a thin, luminous skin, floating on something far deeper, like moonlight trembling on a black ocean that never shows its bottom? I keep returning to this thought on quiet nights, when the sky feels less like a ceiling and more like an ancient presence. Listening. We look up and call it space. But some theories suggest space may have more dimensions than our senses can hold. Not because we are foolish, but because biology is a practical thing. It evolved to track fruit in trees and faces in shadows, not to grasp the architecture of infinity. And so we may be like sailors who learned the surface of the sea by touch and tide, never suspecting the abyss beneath their hull. When physicists speak about extra dimensions, it can sound like distant mathematics, cold and uninviting. But there is a gentler way to imagine it, a way that makes the mind relax into the possibility rather than fight it. Picture a sheet of paper drifting in a vast, dark room. On the paper lives a world of ink beings who can only move forward and backward, left and right. For them, up does not exist. Yet you can lift the paper with 2 fingers and fold it, bringing 2 distant points together in a breath. To the ink beings it would look like magic, an impossible shortcut, a tunnel through reality. If our universe is a kind of membrane, a brain drifting in a higher dimensional bulk, then some of the strangest phenomena we talk about may be shadows cast by that larger room. This is where black holes begin to feel less like graves and more like doors that have been sealed. We are used to thinking of black holes as endings, devourers of light, final sentences written in gravity. Yet there is another mood to them that some scientists and philosophers cannot shake. A black hole is the place where our maps fail, where space-time bends so severely that even the idea of a straight line becomes a kind of prayer. It is the one object in nature that seems to insist there is more to the story than what we can see from the outside. John Wheeler, who gave us the very phrase black hole, also left behind a small sentence that keeps echoing through modern physics. It from bit. It is only 3 words, but it carries an entire worldview. The idea that at the deepest level, reality may be made not of stuff, but of information. And if reality is information, then a black hole becomes something even stranger than a monster. Because black holes forced physicists to confront a sacred rule of the quantum world. That information is not supposed to vanish. This is not a poetic preference. It is one of the pillars of the way our equations remember the past. Yet a black hole seems to swallow not only matter, but the story of that matter. The debate around this problem has been so intense that it has shaped entire careers. And it has pushed people like Leonard Susskind and Gerard T. Hooft toward a radical idea, often summarized as the holographic principle. The name sounds like science fiction, but the intuition is simple enough to taste. It suggests that a 3-dimensional world might be fully described by information written on a 2-dimensional boundary. Like a vast cosmic record etched on an edge we can never quite touch. Now listen to what that implies when we return to the brain picture. If our universe is a membrane floating in a larger reality, then perhaps what we call depth, distance, and even time are emergent sensations, like the illusion of a landscape inside a dream, convincing while it lasts. Carl Sagan once offered a line that feels almost designed for this moment. We are a way for the cosmos to know itself. If that is true, then maybe consciousness is not merely watching the universe. Maybe it is one of the ways the universe reads its own hidden code. And maybe the reason these ideas feel spiritual is not because they are unscientific, but because they touch the edges of what we can be. At this point, the mind naturally asks for something to hold on to. Some example that turns abstraction into an image you can carry through your day. So imagine a calm lake at night. The surface is smooth enough to reflect the stars. And in that reflection, a person could build an entire sky mythology. But beneath the surface there are currents, pressure zones, and deep cold layers that never see the moonlight. The reflection is real, and yet it is not the full reality of the lake. Our universe may be like that surface, a coherent layer where physics holds together and patterns persist. But black holes could be the whirlpools where the surface opens to the depth. Or picture an ant walking on a vinyl record. The ant experiences ridges as hills and valleys, and it might build laws of motion based on that world. But you can lift the record and tilt it, changing the ant's destiny with a movement the ant cannot even conceive. If higher dimensions exist, then gravity might be the one force that remembers them most clearly, because gravity is geometry itself. Some models suggest gravity could leak into the bulk beyond our brain, which might help explain why gravity feels so weak compared with other forces. Even if that specific explanation turns out to be wrong, it shows you the flavor of the thinking. We are not adding fantasy to physics. We are following physics to the place where imagination becomes a tool for survival. Now we arrive at the most haunting possibility in your original idea. What if each black hole is not only a terminus, but a womb? The thought sounds like myth because humans have always understood the world through cycles of devouring and birthing. Yet there are modern proposals that treat the interior of a black hole as a seed for a new region of space-time. In some versions, the crushing collapse does not end in an infinitely sharp singularity, but in a bounce caused by quantum effects that we do not yet fully control. What if the universe you have trusted your whole life is only a thin, luminous skin, floating on something far deeper, like moonlight trembling on a black ocean that never shows its bottom? I keep returning to this thought on quiet nights, when the sky feels less like a ceiling and more like an ancient presence. Listening. We look up and call it space. But some theories suggest space may have more dimensions than our senses can hold. Not because we are foolish, but because biology is a practical thing. It evolved to track fruit in trees and faces in shadows, not to grasp the architecture of infinity. And so we may be like sailors who learned the surface of the sea by touch and tide, never suspecting the abyss beneath their hull. When physicists speak about extra dimensions, it can sound like distant mathematics, cold and uninviting. But there is a gentler way to imagine it, a way that makes the mind relax into the possibility rather than fight it. Picture a sheet of paper drifting in a vast, dark room. On the paper lives a world of ink beings who can only move forward and backward, left and right. For them, up does not exist. Yet you can lift the paper with 2 fingers and fold it, bringing 2 distant points together in a breath. To the ink beings it would look like magic, an impossible shortcut, a tunnel through reality. If our universe is a kind of membrane, a brain drifting in a higher dimensional bulk, then some of the strangest phenomena we talk about may be shadows cast by that larger room. This is where black holes begin to feel less like graves and more like doors that have been sealed. We are used to thinking of black holes as endings, devourers of light, final sentences written in gravity. Yet there is another mood to them that some scientists and philosophers cannot shake. A black hole is the place where our maps fail, where space-time bends so severely that even the idea of a straight line becomes a kind of prayer. It is the one object in nature that seems to insist there is more to the story than what we can see from the outside. John Wheeler, who gave us the very phrase black hole, also left behind a small sentence that keeps echoing through modern physics. It from bit. It is only 3 words, but it carries an entire worldview. The idea that at the deepest level, reality may be made not of stuff, but of information. And if reality is information, then a black hole becomes something even stranger than a monster. Because black holes forced physicists to confront a sacred rule of the quantum world, that information is not supposed to vanish. This is not a poetic preference. It is one of the pillars of the way our equations remember the past. Yet a black hole seems to swallow not only matter, but the story of that matter. The debate around this problem has been so intense that it has shaped entire careers, and it has pushed people like Leonard Susskind and Gerard T. Hooft toward a radical idea, often summarized as the holographic principle. The name sounds like science fiction, but the intuition is simple enough to taste. It suggests that a 3-dimensional world might be fully described by information written on a 2-dimensional boundary, like a vast cosmic record etched on an edge we can never quite touch. Now listen to what that implies when we return to the brain picture. If our universe is a membrane floating in a larger reality, then perhaps what we call depth, distance, and even time are emergent sensations, like the illusion of a landscape inside a dream, convincing while it lasts. Carl Sagan once offered a line that feels almost designed for this moment. We are a way for the cosmos to know itself. If that is true, then maybe consciousness is not merely watching the universe. Maybe it is one of the ways the universe reads its own hidden code. And maybe the reason these ideas feel spiritual is not because they are unscientific, but because they touch the edges of what we can be. At this point, the mind naturally asks for something to hold on to. Some example that turns abstraction into an image you can carry through your day. So imagine a calm lake at night. The surface is smooth enough to reflect the stars, and in that reflection a person could build an entire sky mythology. But beneath the surface there are currents, pressure zones, and deep cold layers that never see the moonlight. The reflection is real, and yet it is not the full reality of the lake. Our universe may be like that surface, a coherent layer where physics holds together and patterns persist. But black holes could be the whirlpools where the surface opens to the depth. Or picture an ant walking on a vinyl record. The ant experiences ridges as hills and valleys, and it might build laws of motion based on that world. But you can lift the record and tilt it, changing the ant's destiny with a movement the ant cannot even conceive. If higher dimensions exist, then gravity might be the one force that remembers them most clearly, because gravity is geometry itself. Some models suggest gravity could leak into the bulk beyond our brain, which might help explain why gravity feels so weak compared with other forces. Even if that specific explanation turns out to be wrong, it shows you the flavor of the thinking. We are not adding fantasy to physics. We are following physics to the place where imagination becomes a tool for survival. Now we arrive at the most haunting possibility in your idea. What if each black hole is not only a terminus, but a womb? The thought sounds like myth, because humans have always understood the world through cycles of devouring and birthing. Yet there are modern proposals that treat the interior of a black hole as a seed for a new region of space-time. In some versions, the crushing collapse does not end in an infinitely sharp singularity, but in a bounce caused by quantum effects that we do not yet fully control. If such a bounce exists, then what we call a singularity might be less like a point of death and more like a passage where space-time changes its costume. Here the metaphor of a cosmic family tree becomes strangely appropriate. Imagine universes as generations, each one inheriting a set of physical constants, the way children inherit a certain shape of face or the rhythm of a voice. A black hole forms, and somewhere beyond our reach, a new cosmos begins to inflate with its own sky, and its own long history of stars is less than $0.5. Number is greater than, and perhaps its own quiet questions about where it came from. Lee Smolin proposed a version of this idea as cosmological natural selection, suggesting universes that make many black holes could have many descendants. You do not have to accept every detail to feel the elegance of the broader thought that endings may be engineered to become beginnings. And when we try to visualize it, we can make it tender instead of terrifying. Think of a seed pod splitting in silence at the end of a season. From the outside it looks like decay, a husk opening under pressure. From within it is simply release, a new starting point slipping into the world. If black holes are seed pods of space-time, then the darkness is not empty. It is fertile. The cosmos becomes a garden of hidden births, most of them forever unseen by any eye that belongs to their parent universe. Of course, there is a line we must not cross when we speak this way. This is still speculative territory, and responsible science demands humility. We cannot yet look beyond an event horizon, and we cannot yet confirm extra dimensions directly. We can only gather clues, test consistency, and search for predictions that might one day be measured. That caution matters, because wonder without discipline becomes a fairy tale. Yet discipline without wonder becomes a desert. The best work often happens on the border between the two. And this is where I offer my own view, not as certainty, but as a quiet personal lesson that these ideas keep teaching me. Even if the brain world is wrong, even if black holes do not give birth to universes, the exercise changes something in the soul of the listener. It trains us to hold reality lightly, to remember that the world we inhabit is not obligated to be intuitive. It also softens the ego, because if our entire cosmos could be a layer within something larger, then how many of our daily anxieties are just ripples on the surface of a deeper sea? There is another gentle lesson here as well. If we truly live inside a universe that might have ancestors and descendants, then existence becomes less like a lonely accident and more like a long lineage of becoming. A chain of worlds giving rise to worlds, darkness giving rise to light, collapse giving rise to expansion. In that picture, the human mind is not an outsider peering at the cosmos. It is a local expression of the cosmos, trying to understand its own origin story. That is why Sagan's line continues to feel so right. We are a way for the cosmos to know itself. So I invite you to sit with one image as we drift forward. Imagine standing on the shore of a midnight sea. The sky above you scattered with stars like salt thrown into velvet. Each star is real, each one burning with its own physics and its own time. Yet beneath that beauty there may be architectures we cannot see, higher dimensions holding the stage, and black holes acting not as monsters but as hinges in the structure of reality. If that possibility stirs something in you, not fear but awe, then write a comment with your honest instinct. Do you feel black holes are endings? Or do you feel they might be beginnings disguised as night? And as you keep watching, hold on to the promise of the journey ahead, because we are about to follow this question into the next chamber of the mystery, where the edge of a black hole begins to resemble the edge of our universe itself. What if the force that keeps galaxies from tearing themselves apart, and the force that makes the universe expand faster with every passing billion years, are not two separate mysteries at all, but a single message written in invisible ink across the sky? When you first hear that dark matter and dark energy make up almost everything, it feels like being told the house you live in is mostly made of rooms you can never enter. You can walk the familiar hallway of stars and dust and planets. You can touch the furniture of atoms. But the true structure is hidden behind walls that refuse to open. And yet the walls are not silent. They speak through gravity, through motion, through the way light bends and time stretches. Consider a spiral galaxy on a clear image, graceful arms turning like a slow pinwheel in the dark. If you trust only what you can see, then the bright stars are the whole story. But the story breaks the moment you measure how those stars move, because they orbit too quickly to be held together by visible matter alone. It is like watching a carousel spin at a speed that should fling the horses into the night. Yet the ride remains steady. Something unseen is providing the grip. This is where dark matter enters not as a fantasy, but as a sober accounting necessity. Astronomers did not invent it to sound mysterious. They backed into it because the numbers would not balance. I often imagine the visible galaxy as foam on a black ocean. The foam is real and beautiful, but it is not the ocean. Dark matter is that ocean in this analogy, not directly seen, but felt in the way it holds the foam in patterns. Then the narrative pivots from binding to drifting, from the grip of hidden mass to the strange expansion of space itself. In the late 1990s, observations of distant supernovae suggested that the universe is not merely expanding, it is accelerating. This is a different kind of astonishment, because gravity should slow expansion over time. And yet the cosmos behaves as if it is being urged onward by a pressure embedded in the fabric of space. That pressure is what we call dark energy. The name is almost too calm for the concept, because what it really means is that empty space may not be empty at all, that the vacuum could carry an energy that pushes outward relentlessly. If dark matter feels like unseen scaffolding in the cosmic architecture, then dark energy feels like the slow widening of the room itself. The walls of reality inch away from each other, not because anything is moving through space faster, but because space is quietly growing more space. So we stand before a universe that is mostly invisible and mostly active. Something we cannot see holds galaxies together. Something we cannot see drives galaxies apart. And when you place these two facts side by side, you feel the mind doing what it always does at the edge of comprehension. It looks for a deeper unity. Are dark matter and dark energy separate substances? Or are they symptoms of a single underlying geometry we have not yet decoded? Here I like to borrow the spirit of Einstein's perspective, that gravity is not a pull through space, but the shape of space and time themselves. If gravity is geometry, then perhaps the invisible majority of the cosmos is telling us that our geometry is incomplete. Perhaps we are reading a map with missing symbols, insisting the land is wrong because our legend is wrong. Now, place a black hole into this picture, not as a monster but as a teacher. We have photographed the shadow of one, a ring of glowing matter circling a darkness that refuses to return light. That image is more than a triumph of engineering. It is a cultural moment. It says that the universe contains boundaries that are real and absolute, not merely poetic. We have also heard black holes through gravitational waves, those faint ripples in space-time produced when two massive objects spiral together and merge. In that moment, the universe does not merely show you a picture. It presses a vibration into your instruments. It is as if reality has a skin and it can ring like a bell. These detections carry an emotional charge that is hard to describe, because they remind us that the cosmos is not silent material scattered in emptiness. It is a living geometry with memory and motion. And yet every one of these achievements stops at the event horizon. The event horizon is not a physical wall you could touch. It is a boundary of return. Cross it and no signal can climb back out to tell the tale. That is why black holes feel like philosophical objects disguised as astrophysical ones, because they confront us with a limit on observation itself. We can infer what happens near the edge. We can test predictions of relativity with exquisite precision. We can watch matter heat and swirl and shine as it approaches the boundary. But we cannot point a camera beyond that line and bring back the footage. As Stephen Hawking famously put it, black holes are not entirely black. Even if we treat that as a doorway into the deeper discussion of Hawking radiation and information rather than a simple slogan, the meaning remains potent. The darkest places in nature may still leak a whisper of themselves back into the universe. Slowly, patiently, almost tenderly. This is where the speculation you raised begins to glow on the edge of reason. The idea that our universe could be inside a larger black hole. I do not present it as certainty, only as a hypothesis that seduces the imagination because it rearranges familiar pieces into a new picture. From the outside, the formation of a black hole is collapse. From the inside, could that same event resemble an expansion? Could what we call the Big Bang be the interior perspective of a gravitational collapse happening in apparent reality we cannot observe? If so, then the fact that our evidence stops at a horizon would no longer be an accident. It would be the architecture of our existence. The cosmic horizon that limits what we can see might be related in spirit to an event horizon, not necessarily identical in the naive sense, but echoing the prius, same principle, that there are regions whose information cannot reach us because of how space-time is shaped. Now return to dark matter and dark energy with this lens. If our universe is an interior region with a boundary we cannot cross, then the invisible forces might be the way the boundary manifests inside the region. Dark matter could be the signature of how the larger geometry constrains structure within our cosmos. Like the way the shape of a bowl guides the flow of water, even if the water never sees the bowl's full outline. Dark energy could be the pressure of the boundary itself, evolving over time. An outward tendency written into the vacuum by the deeper spacetime beyond our reach. Again, I am not claiming this is the answer. I am pointing out why the question is worth sitting with. Because it tries to connect three haunting facts. That most of the universe is invisible. That black holes create absolute observational horizons. And that our own cosmos has a horizon that limits what we can ever know directly. To make this feel tangible, imagine living in a vast cathedral with no windows. You can map the echoes of your voice and determine where pillars must stand even if you never touch them. Dark matter is like the unseen pillars inferred from the way the sound reverberates. Dark energy is like a slow widening of the cathedral's interior that you detect only because the echoes take longer to return. You never see the outer stonework. You never step outside to view the building from the street. But you learn its hidden proportions through the behavior of waves and motion within. This is essentially what cosmology has become. A study of the unseen by the discipline of consequences. And this discipline has a quiet spiritual lesson for me. One I try to carry beyond science and into the way I live. It teaches humility without surrender. It says our models are powerful but provisional. Our measurements are precise but bounded. Our certainty is always smaller than the cosmos that contains it. It also teaches patience, because the universe does not reveal its deepest mechanisms on the timescale of a human news cycle. Sometimes it reveals them across generations of instruments and minds. We built telescopes to see galaxies. Then we built detectors to hear space-time. And each leap opened a new room in the mansion of the unknown. So when someone asks, what holds galaxies together? And what pushes the universe apart? I hear a deeper question beneath the physics. Are we mistaking the visible for the real, and the invisible for the absent? The history of science warns us against that mistake. Gravity was once invisible and only felt. Microbes were once invisible and only inferred. Atoms were once invisible and only imagined. The invisible does not mean unreal. It often means we have not yet built the right sense organ in the form of an instrument or a theory. And perhaps that is the final value of this whole thread of thought. Whether or not the black hole universe idea survives future tests. It invites us to treat the cosmic horizon with respect rather than frustration. To accept that there may be boundaries in nature that we cannot cross, while still believing we can learn an astonishing amount by studying the edges carefully. If we cannot step beyond the horizon, we can still become masters at reading its shadow, its lensing, its ripples in space-time. And in doing so, we practice a kind of cosmic meditation, not passive, but attentive. A willingness to sit with mystery without turning it into mythology or dismissing it as nonsense. Because maybe the universe is not only a place we inhabit, maybe it is also a question that is slowly learning how to ask itself through us. What if the universe you call home is only a thin layer inside something vastly larger, like a soft ripple on the surface of an unseen ocean? What if reality is a projection, not because it is fake, but because it is encoded somewhere we cannot touch? And what if human consciousness is the universe looking back at itself, not with eyes of flesh, but with awareness born from stardust? These questions feel almost dangerous to hold in the mind, because they rearrange scale and meaning at the same time. They make us smaller than dust in a cathedral of galaxies. Yet they also make us strangely central, like the one candle whose flame reveals the room. Carl Sagan once offered a line that still lands like a meteor in the heart. We are a way for the cosmos to know itself. If that is even partly true, then your doubts, your wonder, your quiet, late-night questions are not side effects of existence. They are part of its function. To picture a projected reality, imagine a hologram on a bank card. Tilt it slightly and an entire three-dimensional image appears from a thin sheet of pattern and light. Or think of shadow puppets on a wall, where a flat silhouette hints at hands, moving in a dimension you cannot see directly. Physicists have wrestled with the possibility that information may be fundamental, that what we call space and time might emerge from deeper rules. John Wheeler distilled this into a phrase as sharp as flint. It from bit. Not poetry for its own sake, but a suggestion that reality may rise from information the way a symphony rises from notes. And then there is Einstein, who reminded us that the most beautiful thing we can experience is the mysterious. I return to that line whenever I feel the old, human fear of not knowing. Because the mystery is not an insult to science. It is the invitation that keeps science alive. If our universe is a layer inside a larger structure, then our instruments may be like seashells pressed to the ear, catching only a small part of the ocean's voice. We might never see the full architecture, yet we can still learn the rhythm of the waves. Here is my personal view. The most profound consequence of these ideas is not whether they are ultimately proven in the strictest sense, but what they do to the way we live today. If reality is deeper than it looks, then cruelty becomes even more senseless, and kindness becomes even more cosmic. If consciousness is the universe observing itself, then every moment of attention you give to life is a kind of sacred measurement. And if history is not only something we learn, but something we gradually remember, then perhaps the real journey is not outward alone, but inward as well. So tell me, does this possibility make you feel small, or does it make you feel chosen by existence to witness it? Because in the next part, we step closer to the edge of the story we were taught, and ask the question that changes the entire direction of the sky. What if the Big Bang wasn't the beginning,